Welcome to Teaching Elixir, where we introduce my friend, an already experienced developer, to more and more of Elixir. So this time it's all about strings. Hello, Andreas.
Good morning.
Yeah, recording these in the morning is interesting. It's like
Yes.
the voice is really not warmed up, but hopefully it's bearable for people watching. All right, so strings. Thought we had covered this already almost.
Yeah.
But if we look closer, it's strings, char lists, graphemes, and code points. And I think we've touched on strings and char lists,
Yep.
but I don't think we've done anything with regards to code points.
Okay.
So I don't think we've done anything with graphemes or code points. But there's also probably a bunch of additional details about strings that we're going to cover, because I think we've run through strings as part of what types are available, but not really in depth.
Indeed.
Yeah. So the first example here says Elixir strings are nothing but a sequence of bytes. Let's look at an example. And they are assigning a string or binding a string. I don't know why it's called binding, but formally it's binding a variable. It's
I
not
think
assigning a variable, but it's binding.
because you're binding a name to a value.
Yeah. It's part of the formalities I don't grok. But
Yeah.
so it's just putting in a sequence of bytes, which are numbers in this case. And if we evaluate it, it goes, hello.
Sweet.
And then it tries a thing where it concatenates a 0 byte to it, which I guess is a null byte as well.
Yep.
And that turns it back into a sequence of bytes. So by concatenating the string with the byte 0, IX displays the string as a binary because it's not a valid string anymore. This trick can help us view the underlying bytes of any string. I think it's turned into what would be sort of a C string, right?
Yep.
It's null terminated.
So these strings are not C strings. That's good.
Well, not at the Erlang layer, I don't think. Yeah.
Yeah. An implementation detail. Cool.
So apparently we're going on to char lists, and I think we'll return to strings here and there. So internally, Elixir strings are represented with a sequence of bytes rather than an array of characters. So trying to grok exactly what this means, a sequence of bytes.
Yeah, they are a contiguous contiguous, is that a word?
Yeah.
Sequence of bytes in memory.
Yeah,
So,
okay.
That makes them fast.
Yeah. Wouldn't an array also be fast, though?
Yeah.
Well, rather than an array of characters. Elixir also has a char list type character list. Elixir strings are enclosed with double quotes, while char lists are enclosed with single quotes. What's the difference? Each value in a char list is the Unicode code point of a character, whereas in binary the code points are encoded as UTF-8. Also worth noting, char lists has been very common in Erlang. So that's typically how a string is represented in Erlang. So when you're dealing with some Erlang APIs, you may need to pass them char lists.
Okay.
So if we ask for hello, we get that. If we add a 0 byte to it, we get that.
Yeah. I think a char list is a linked list, which makes it excruciatingly slow on modern hardware.
Yeah, so since they are, a char list is just a kind of list, and Erlang lists are linked lists. You're probably correct there. I was confused by that rather than an array of characters, because array is a very specific thing as well, but not in this language.
Yeah, and a linked list it's not a contiguous, it's not guaranteed to be contiguous. It can be anywhere in memory, which messes with the cache.
Yeah. I think overall it doesn't matter a lot that Elixir and Erlang lean so much on linked lists.
Yep.
In the grand scheme of things, it's fairly minor. But that would be, and there are sort of alternate data structure implementations and stuff that are more effective or more efficient for different kinds of things. Erlang has a few of them built in.
Yep.
But probably there would probably be some merit to having like another list implementation that could be used similarly conveniently.
Yeah.
For certain uses, but yeah, typically not a big deal from what I've seen. But I've definitely seen arguments about it. But what we see here is that there are, so it's 104, 101, 322, 322, 111, while in the Elixir case it's 104, 101, and then these are higher Unicode numbers. We can just see that these are added together in the Erlang one.
Oh. Yeah.
For this special L with a slash on it.
Yeah. The w.
The wa.
Yeah, I think it's pronounced that way.
So this is hawawawa?
Yep.
Great.
The woob woob string.
322 is the Unicode code point for L slash, but it's encoded in UTF-8 as the 2 bytes. 197 and 130. You can get the character's code point by using question mark. So if we say question mark Z, we get 90. This allows you to use the notation rather than Z for a symbol.
Yep.
So 130, what's that?
130. That's a good, I don't know. Can we go the other way around?
So that would be code block contains unused literal blah blah blah. Yeah, so I don't think it can print as a string, that part.
Wait. Yeah, okay.
Because if I did
it's warning about
90
the question mark Z, right?
Yeah, okay. I'm not using that.
Got it.
So if I'm making a binary with just 90 in it, that's a string, because it's in the, I guess it's in the Unicode displayable stuff.
Yeah, I think what 197 does is put you in another namespace.
Oh, that's cool.
Yeah,
love a namespace.
Yeah, let's continue and see if we get any hints about it.
Yeah. They also note that when programming in Elixir, we usually use strings, not char lists. The char list support is mainly included because it is required for some Erlang modules.
Yep. Graphemes
and code points. Code points are just simple Unicode characters, which are represented by one or more bytes, depending on the UTF-8 encoding. Characters outside of the US ASCII character set will always encode as more than 1 byte. For example, Latin characters with a tilde or accents are typically encoded as 2 bytes. Characters from Asian languages are often encoded as 3 or 4 bytes. Graphemes consist of multiple code points that are rendered as a single character. The string module already provides 2 functions to obtain them, graphemes, code points. Let's look at an example. And this stuff is incredible. I'm super glad that they have a clear separation of these. Yep. So you if you evaluate these things, so that's an accented A, and if you want the code points, you get the A and the accent, and if you want the graphemes, you get the whole shebang.
Let's see, is that dirt on my screen or no?
That's
the accent is
inside the double quote.
Oh yeah. Okay. Yeah.
Let's see. There's Is there a string.length? I don't remember.
We'll soon know.
Yeah.
Yes.
So that string counts the number of graphemes.
Yeah.
We'll probably get into this as well, but I
That's
wonder
important.
if I just use length. No, that's not a list, right? But if I use byte size,
Yep.
that's 3.
That makes sense because first we have the this is exciting byte, and then we have the A byte, and then we have the thing byte. I'm only using technical terms here.
Yeah. All right. If you say so. So actually, if we do this, we should see the byte sequence.
Yep. Huh, I was wrong about the first byte. That one's 97 instead of 197, which we saw above.
I think 97 is the A. Because
it rings a bell.
Yeah, because big Z was 90. Then you have probably have some characters in between, and then you have those lowercase letters.
Yeah.
String functions. Let's see. Length returns the number of graphemes in the string.
Nice.
Replace returns a new string, replacing a current pattern in the string with some new replacement string. Hello. Duplicate returns a new string repeated n times. Oh, I've never used that, but maybe I should. So for a single character, I can see how that would be sort of useful for padding or whatever. Well, you didn't crash it, so that's good.
Yep.
Please restore it.
I don't remember how.
Oh,
like
my.
Oh, no. What? Okay. Yes.
Returns a list of strings split by a pattern that's split.
Yep.
It also has something I like, which is so let's see if we hello world again here. So you can limit how many times it will split. So if you're dealing with a very specific format and you know you want to split by this thing, but then there might be any number of the split mark later that you don't care about, you can just say, I don't care about that.
Cool.
I think string replace has times as well.
Okay.
Let's see if that's the case. 1. No. I just might not be remembering the right option. Or no. Okay. An exercise.
Woo-hoo.
Let's walk through a simple exercise to demonstrate we are ready to go with strings. Anagrams. A and B are considered anagrams if there's a way to rearrange A or B, making them equal. For example, super and Paris. If we rearrange the characters on string A, we can get the string B and vice versa. So how could we check if two strings are anagrams in Elixir? The easiest solution is to just sort the graphemes of each string alphabetically and then check if they both lists are equal. Let's try that. So I have this module.
Yep.
Anagrams question mark. A, B, when is binary, da 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 da. Okay.
Yeah.
Sort string, in comparison. So string down case, graphemes, sort.
Yes. Cool.
So they did the exercise.
Hey.
That's the best kind of exercises, the ones I don't have to make. Yeah. So yeah, this is no function clause matching because we have these guards checking whether it's a binary.
Yeah.
So that's intended.
Fair enough.
Cool. I think that was the entirety of the string module. We still have the date time in the basics to cover. And I think we might, just for completeness sake, figure out a time to do that as you're getting back into actual work and starting to work with Elixir.
Yeah, cool, eh?
And then I think we should sit down and have a small project where we build. I'm thinking that we should probably build an actor, so setting up a gen server to do something. That will probably not be in Livebook just because, it's doable in Livebook, but I don't think that's the sweet spot for using Livebook, so we might do it in something else.
Yep.
And then you've said something about introducing me to witchcraft.
Yeah. I'm gonna take a serious look into witchcraft and see if I can teach you something.
Cool. All right, that's it for now. Thanks for watching.